So the next one is rendering path, and there are 4 different rendering paths. I'm going to discuss them all. So the first one is forward rendering. So you will be using forward rendering when you have very few lights in your scene. Like in my situation, I have only one directional light. In that case, you can use forward rendering. However, if there are lots of shadow casters in your scene, in that case, you might not want to use forward rendering. So I'm going to show you an example. So currently you will see that the total number of batches I have is 244 and triangles 1.1 million. And currently my rendering path is forward. If I change this to deferred, you will see that the total number of batches go down to 150 and triangles go down to 853,000. This is because forward rendering cannot perform very well if there are lots of shadow casters in the scene. In my situation, all these trees are casting shadows, and that is why the total number of draw call goes higher. If I increase the number of trees, it will get even worse. However, deferred rendering does not have these issues. If you have lots of different types of shadow casters in your scene, or if you have lots of different types of lights in your scene, in that case you might want to use deferred rendering. Now you might ask, why not use deferred rendering all the time? Because deferred rendering has some disadvantage as well. Like, deferred rendering does not support multi-sampling anti-aliasing, as you can see it's written over here. However, you can achieve a similar effect by using the post-processing stack, and I will be making videos about post-processing in the future videos. The second thing is that deferred rendering is not supported on all different types of hardwares. Also, you can notice here the hardwares where the deferred rendering is supported, and the forward rendering, you will see that it's supported in all different types of hardwares. So it totally depends on your situation and your scene, so you might want to change these different values. Also, deferred rendering has some other disadvantages, like it cannot render semi-transparent objects. So the next one is the legacy vertex slit, which is the old shader, and it does rendering based on vertex only. Also, it does not support real-time shadows or different types of shadows. So if I turn it on, you will see that it does not even render my terrain. So most of the time you will not need this. So the last one is legacy deferred, which is very similar to deferred. Also, I forgot to mention, legacy vertex slit is a subset of forward rendering. Anyways, legacy deferred is a similar to deferred, but the way it works is different in comparison to deferred, and you can also say it is an older version of deferred rendering. However, there is one difference between legacy deferred and deferred, which is that legacy deferred draws all the objects 2 times. Now I will show you an example of this. So currently if I move to deferred, you will see that the total number of batches is 150. So if I change to legacy deferred, you will see that the total number of batches almost go to 300, which is the double of 150. So most of the time you will have to choose between forward deferred or legacy deferred according to your game and according to your scene requirements. I would suggest starting with forward and then going back to deferred or legacy deferred. Also, the cheapest shader is the legacy vertex slit. However, it's way too simple, so you might not want to use it.